Alright, for problem number 70, start with the force diagram. And I'm going to start with the force diagram of the block that's on the table. And so I'm going to label this force due to gravity 2 since it's the 2 kilogram block. Now I'm also going to need a force diagram of the 1 kilogram block. It's the same cable, so I'm going to call it force tension and force due to gravity 1. The blocks are coupled together, so what I can do is I can take the diagram from 1 and plug it into 2 and create what is called a system diagram. And on the system diagram, all I'm interested in is the forces that act outside the objects, outside the system consisting of block 2 and block 1. Notice in this case the tension, this is the connection between the objects, or rather maybe I'll say the interaction between the objects. So if the two objects are now contained in the system diagram, that interaction is internal, and we only have external interactions listed on your force diagram. Okay, so now what I can do is I can sum up the forces. In the x dimension I have force due to gravity 1, and it's pointing to the right. In the y direction I have force due to gravity 2, and it points down. And I have force normal, and it points up. Notice this is the AX, this is the AY. Relative to this system diagram, I've taken the system to mean something kind of like this. I have the 2 kilograms, I have the 1 kilogram. This is my equivalent system. Well, this system is on the surface, it's confined to the surface. What that means is my acceleration in the x direction, or I should say the y direction, goes to 0. So I can say that the force normal is equal to the force due to gravity 2. Or more importantly, I can say in my, well actually, what was my question asking? Oh, I forgot one thing on the diagram, didn't I? We do have friction, so I better make sure I have friction here. And I better make sure I have friction here. There we go. Which means I need to update this one. There we go. Now that tells me what I need to do in the y direction. I need to get a number for force normal. Well, force normal is force due to gravity 2. Well, that's mass 2 times gravity. That's important because force of friction is equal to coefficient times the force normal, or in this case, coefficient times mass 2 times gravity. That's something I can substitute into the first case. The x case rather, I should say. I have force due to gravity 1, which is m1g, plus force of friction, which is this equation right here. So I have mu m2g. and that's the opposite of from my equation at the top there. And that's equal to m. Now notice this is the system mass. The reason it's the system mass is because this equation only applies to the system diagram that I have right there. What that means then is I have m1 plus m2, that's the system mass, times my acceleration in the x direction. And I was after acceleration, right? Yeah, what is the coefficient, or what is the acceleration? So this ax is my acceleration, so ax is equal to m1g plus the opposite of mu m2g all divided by m1 plus m2. And then now I can put in my numbers. Block 1 was 1 kilogram, 9.8 newtons per kilogram. 0.2, yeah, 0.20. That was your coefficient of friction. 2 kilograms is the block mass. 9.8 newtons per kilogram, Earth's gravitational field, or you could think of it as an acceleration, however you like to think about it. And then 1 kilogram plus 2 kilograms. And we can put that into our calculator, and we'll get our number. Let's see, I gotta find my calculator, so I'm gonna pause. Alright, got that put in my calculator, and that gives me an acceleration of 1.96 meters per second squared. Now the problem actually asked me what's the upper block's acceleration, and the upper block is the one that I used the system diagram for. Actually, the system was both blocks, but for the system diagram, I took the perspective of the block, the 2 kilogram block, the one that was upper. So what that means is you're going to have 1.96 meters per second squared to the right. That's the same acceleration that block 2 would have going down. It's just that would be acceleration for the 1 kilogram block. This would be acceleration for the 2 kilogram block, and since they're coupled together, they have to have the same acceleration. So that takes care of problem number 70.